Hi, so for today we're going to talk about matrix operations, and this video will fall under my tutorial under the playlist of the college algebra. Okay, so before I start my tutorial, let me just thank all of you for your support. Now that we have 3,000 subscribers, so thank you so much for sharing and continuing watching my tutorial videos in engineering mathematics and probably some of the physics subjects that I have uploaded on my channel. So thank you so much. And today we're going to talk about matrix operations. More specifically, addition, subtraction, multiplication, and transpose of a matrix. So before we do some operations regarding matrix, involving matrix, so let's first recall that a matrix has a size or dimensions, okay, wherein its size or dimension is indicated by m by n, where m is the number of rows and n is the number of columns. Okay, so as we can see here, columns. So as we can see here, we have four. Okay, we have four matrices here given, and what I'm going to do is to have a simple operation regarding these matrices. Okay, so and again, the counting of rows is this, okay, and the counting of columns is this. So that if I have a matrix like this, okay, matrix involving like this, so I have the first row, that is the R1, first row, and the second row, that is the R2, and third row, that is the R3, and I have the first column, we have column 1, second column, column 2, and third column, we have column 3, okay? So that is how the rows and the column are identified in our matrices. Okay, so because it's important in solving the operations of matrix. Okay, so for number one, we can we find the matrix A plus B? If I'm going to rewrite matrix A, 2, -3, 0, 5, 7, and -1 have here, plus matrix B, which is 1, -3, 2, and 0, 1, 2. Can we add these two? Now, you need to remember a simple rule when adding or subtracting matrices. So, you can only add or subtract matrix if and only if they have the same dimension. I repeat, if they have the same dimension. If matrix A and matrix B have the same dimension. So, what is the dimension of this matrix? Row 1, row 2, row 3. So, we have 3 here. 3 by 2 columns. So, 3 by 2. And the dimension of this matrix also is 1, row 2, row 3, column 1, column 2. So, 3 by 2. Hence, we can add them. Okay? And how do we add matrices? Okay? The resulting matrix of A plus B is also the same size, which is a 3 by 2. So, how do we add? Simply, we add 2 plus 1. That is the row 1, column 1 of A plus the row 1, column 1 of B. And again, this is row 1, okay? Row 1, column 2 of A plus the row 1, column 2 of B, which is a 0, and so on and so forth, okay? So we have 5 plus 1, we have 7 plus 2 here, 7 plus 2, and we have -1/2 plus 2 here, okay? So if we're evaluating it, so we have 2 plus 1 is 3, -3 plus 0 is -3, 0 minus 3 is -3, 5 plus 1 is 6, 7 plus 2 is 9, -1/2 plus 2 is 3/2. Okay? So this should be our answer. So there will be no problem if we are adding two matrices that has the same dimension. We simply add their element by element or subtract their elements by their elements. Okay? So that is our for problem number 1. Let me just erase this. Okay. So for problem number 2, we're going to solve this problem. So we have C minus D. Okay. never mind the circles there, C minus D, matrix C minus matrix D. As you can see, they have also the same size or dimension, so we can definitely perform the subtraction or the difference between them. The same dimension will be produced is 2 by 3. Okay? So, the element subtracted by its element. So, what will happen for this part, okay, row 1, column 1, so we have 7 minus 6, okay? 7 minus 6, we have negative 3 minus 0, negative 3 minus 0. We have 0 minus negative 6, okay? Be careful with the negative. Let me just rewrite, okay? 0 minus negative 6. This is negative 6. Okay. And of course, 0 minus 8. 0 minus 8. 1 minus 1. 1 minus 1. 5 minus 9. Okay. And the resulting matrix would be 7 minus 6 is 1. Negative 3 minus 0 is negative 3. 0 minus negative 6. The negative will be distributed here so that negative times negative would become positive. Okay, 0 minus 8 is negative 8, 1 minus 1 is 0, 5 minus 9 is negative 4. As you can see, the dimension of the resulting matrix is the same as the dimension of both matrix A or both matrix C and matrix D. Okay, this given matrix C and matrix D is also the same as the given here. Okay. Okay, let's proceed with another problem. Okay, so let's proceed with another problem. Matrix C plus A. I'm going to copy matrix C. Matrix C is 7, negative 3, 0. Okay, 0, 1, 5. That is matrix C plus matrix A is 2, negative 3 from our above, from our given. Okay, from our given here. Okay, 2, negative 3, 0, 5, 7, negative 1 half. Okay. So the very first thing you're going to do, again, is to check if the dimension of two matrices are the same. So in this case, we have two rows. We have three columns. This is 2 by 3. And this one is 3 rows and 2 columns. Definitely, we cannot add this. If we add two matrices that has a different dimension, that is an undefined. Okay, it cannot be added. Why? Because they don't have the same dimension. That's simple. Okay. So for number 4, a scalar multiple of 5 multiplied in the matrix A. So what will happen? 5 multiplied by the matrix A, our matrix A is 2, negative 3 is 0, 5, 7, and negative 1 half. Okay? So what will happen? 5 will be distributed on every element. 5 will be multiplied on each of the element of matrix A. So what will happen? We have 5 times 2, okay? 5 times 2, negative 3 times 5, 5 times 0 here, and 5 times 5 here. We have 5 times 7 here, and we have 5 times negative 1 half here. So our result would be 5 times 2 is 10, negative 15, this is 0, this is 25, this is 35, this is negative 5 halves. This should be our resulting matrix of a scalar multiple of 5 multiplied in the matrix A. Okay? Okay, let's go now to multiplication of matrix. Let's consider that we have a matrix A that is in this format or given, right? And we have matrix B as here, okay? There is a great rule in multiplying matrices, okay? The very first thing you're going to do when performing operation in matrices is to make sure to know the dimension of each matrix involved in the operation. So we have matrix A, okay? What is the size or the dimension of the matrix A? So we have, that's correct, we have 3 rows and we have 1 column. for the matrix B, we have 1 row and 3 columns. 1 row, 1, 2, 3 columns. Right? Here is the thing. If we are to find A multiplied by B, okay, so not all matrix can be multiplied. There's also a rule. Okay, you need to find the size or the dimension of the matrix of the both two matrices. Okay, in order. Okay, A times B, A and B. Size of A, size of B. Dimension of A, dimension of B. So if the number of column of matrix A is the same as the number of rows of matrix B, then we can multiply those two matrices. Okay? If these two values, is the same. Okay? For A times B. Okay? So, and the resulting matrix of A times B would be actually what? The number of rows of column or of matrix A and the number of column of matrix B, which is a 3 by 3. So if we multiply these two matrices, the result should be a 3 by 3. Okay? So if we're going to write A times B matrix, we will be having A11, A12, A13, A21, A22, A23, A31, A32, and A33. So this is the representation of a 3 by 3 matrix. What does A11, A12 mean? So A11 is the element in the row 1, column 1 of the matrix A multiplied by B. Okay? Same as row 1, column 2, row 1, column 3, it denotes their position inside the matrix. Okay? A21 is row 2, column 1. Okay? A22 is row 2, column 2. A23 is row 2, column 3. Okay? It is where it is located. Okay? And so on and so forth. Okay? So we have A31, row 3, column 1. So A32, row 3, column 2. A33, row 3, column 3. And we need to find all of those values in order for us to get the multiplication of this matrices, right? A times B. So how do we do that? For this position, okay, for this element, this is row 1, column 1. Oh, listen very carefully. Row 1, column 1. Row 1 of matrix A, okay? Row 1 of matrix A, what is that? 2, okay? Multiplied by column 1 of matrix B. Row 1, column 1, that's denoted by 1, 1. Row 1 of matrix A, which is 2. Column 1 of matrix B, which is 2 also, and we multiply that. That is our A11. How about for A12? Row 1 of matrix A and column 2 of matrix B. So that is, we multiply that 2 times 1. Okay? In fact, that is a summation, or what do you call this? The sum of products of all of the rows and columns. So since we only have one element in terms of row in A and one element in terms of the column in B, this is our result. Okay, but later on we will see the difference when we have numerous rows and columns. Okay, so for A13, row 1, which is the 2, row 1 of row 1 of matrix A multiplied by column 3 of matrix B, that is again 2, so on and so forth. Row 2, again, A21 is row 2 of A, which is 1, column 1 of B, that is multiplied by 2, A22, 1 again, okay, multiplied by column 2 of B, that is 1, A23, row 2 of A, which is 1, multiplied by column 3 of B, which is 2, and A31 is row 3 of column A, which is 3, and column 1 of B, that is 2, A32, row 3 of A, which again 3, and column 2 of B, which is 1, and A3, 3. Finally, row 3 of column or row 3 of matrix A and uh, column 3 of matrix B. So we have 3 times 2 because row 3, column 2. Okay? So upon performing that, we shall be getting our answer, which is a 3 by 3 matrix. We have 4, we have 2, we have 4 here. 2 times 1 is 2, 1 times 1 is 1, 1 times 2 is 2, 3 times 2 is 6, 3 times 1 is 3, and 3 times 2 is 6. So that should be our answer for this multiplication problem of matrix. Okay? And for you to further understand, okay, let's have another example. So for our example, okay, for our example, we'll be having two square matrices. Okay, so we have matrix A. When we say square matrix, the number of rows is equal to the number of columns. So that is called a square matrix. 1, 2. We have 3, 2. Okay, and we have matrix B, which is -1, -3, 2, 6. Okay? Again, when multiplying matrix, we should identify first their dimensions. Okay? So, the dimension of this A is 2 by 2, as you can see. 2 rows, 2 rows, 2 columns. Okay? And again, this also is a 2 by 2 matrix. So, my question is this value the same as this if we are to get A times B? Okay? Yes, it is. So we can multiply it. And the resulting matrix, if we multiply matrix A and matrix B, is this value, 2 by 2 also. So we are expecting that if we multiply these two matrices A and B, we will be having a matrix that is a 2 by 2 in dimension. So we have A11, we have A12, A21, and we have A22. Okay? So what will happen? Again, what are we going to do? We're going to get the sum of the products of all the rows and columns depending on the position of that element we're going to get. Okay? For this element, A11, okay, row 1 multiplied by the column 1. So what will happen? Row 1, okay, the row 1, 1, okay, 1 times -1, did you get? Okay, plus, okay, the sum of the products of row 1 of A and column 1 of B. The sum of the products, 1 times -1, this is the row 1, this is the column 1, 1 times -1, here it is, plus 2 times -3. So we have 2 times the -3. Row 1, column 1, sum of their products. So 1 times -1 plus 2 times -3. That is the element for A11. How about for A12? Okay, row 1 of A, column 2 of B. So we have 1, okay, times 2 plus, okay, that's always a plus because sum of products. Row 1, column 2, 1 times 2, 2 times 6. Okay? Okay? So, for A21, row 2, column 1. So, we can see 3 times -1. That's correct. Okay? Plus 3 times -1 plus 2 times -3. 2 times -3. And how about for A22? Lastly, we have row 2, column 2. So, we have 3 times 2. Okay? Plus 2 times 6. Okay? So, here it is. Our resulting matrix A times B. So, we have now -1 minus 6 because 2 times -3 is -6 plus -6, that is -1 minus 6. 1 times 2 is 2. Okay? Plus 6 times 2 is 12. Okay? 3 times -1 is -3 plus, okay, plus 2 times -3, that is -6. Okay? 3 times 2 is 6 plus 2 times 6 is 12. Okay? So our resulting here is -1 minus 6 is -7. 2 plus 12 is, yeah, 14. Okay? 3 plus -6, it would result to -3 minus 6, that is -9. 6 plus 12 is 18. That is the multiplication of our matrix A and B. Okay? Okay, let's try another one. Okay? For our problem number, I think this is number 7. Right? Let's multiply again matrix. Okay? So we are given a matrix A, -1, 2, -7, 5. Okay? And we have matrix B, we have -1, 2, 3, 7. Okay? So again, we should identify first, again, the what? You are correct. The dimension, 2 by 2. And this is also a 2 by 2. If this is equal, then we can multiply them if we are to find A times B. Okay? If these two are equal, that is the resulting matrix of A times B. So let me just rewrite again. A11, A12, A21, and A22. Okay? A11 means, again, row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. Okay? So what are we going to do? Again, A11, row 1, column 1, summation of products of row 1 and column 1, we have -1 times -1, -1 times -1 plus 2 times 3. Okay, that's for A11. A12, row 1, column 2. So we have -1 times 2 plus 2 times 7. Okay, 2 times 7. For A21, row 2, column 1, that is -7 times -1, -7 times -1, plus, okay, 5 times 3. 5 times 3. And for last number, we have last element, A22, we have row 2, column 2. So that we have, okay, -7 multiplied by 2 plus 5 times 7. Okay. So if we evaluate that, our matrix A multiplied by matrix B should be, we have 1, because -1 times -1 is +1, plus 6. Okay. And here we have -2 plus 14. Here we have 7. Okay. Plus 15. We have -14 here plus 35. Okay. So if we evaluate that, that should be 7. We have 12 here. 7 plus 15 is 22. -14 plus 35 is 21. Okay. So here is our result for that multiplication of our matrix. Okay. So that's it. So lastly for this video, okay, we need to evaluate. This is number 8. Okay. Need to evaluate the what we call the, if we are given a matrix 1, 2, 3, okay, we need to evaluate what we call the transpose. This is A transpose of matrix A. So what does the transpose do is to interchange the columns and the rows. Okay. So for example, we have here a matrix A 1, 2, 3, that the dimension of that is 1 row, okay, 1 by 3, okay, 1 row, 3 columns. So if we transpose this dimension should be inverted such that it would become 3 by 1, okay. So we will what? Interchange the columns and rows. So what will happen to this? This would be 1, 2, 3, such that it became a 3 by 1 matrix. Okay? Simply interchanging the rows and columns. So let's try again another transpose problem. So we have 2, 1, okay, -1, 0. Okay? If we get the transpose of that, okay, B transpose, let's say, what will happen? We simply interchange the rows and columns such that it becomes 2 and -1. Here it is. Okay, it became this column became rows, 2, -1. Okay, and this column 1, 0 will become rows. will become rows. Okay? So that this is the transpose of our matrix. Okay? Another example, if we are given a matrix C, okay, we are asked to find the transpose of matrix C, okay, in a 3 by 3 manner. Okay? So again, C transpose. So what are we going to do is this row, okay, or this column will become rows. So if we transpose this is a 3 by 3. If we transpose this, interchange the number of rows and columns, that is still equivalent to a 3 by 3 matrix. So this column will now become rows. 2, 1, this is now the row. And this column will also become rows. Okay? So we have negative 1, 3, negative 10. And of course, this column will now become a row. 0, 2, 6. Such that this is our transpose matrix. Okay? So I hope you guys learned something from our lesson for today, all about the basic operations of matrix. And I hope, okay, and I hope you can answer some basic problems involving matrix operations. So thank you so much for listening, and God bless you.